110/24, I want to choose the gateway 2222. So this route cannot be active simply because the DHC, the gateway is not reachable. Okay, but there is the way to keep this route active with recursive next hop resolving. If I use recursive next hop, this gateway gets active recursively via the main gateway. What is the meaning of this? Actually, this scenario is mostly good for like BGP between. For example, through the internet, there is the gateway here to another LAN. You want to reach it. You are here in another LAN. You are here. So because this gateway is not exactly next hop and it's not one of the connected routes, it cannot be reachable. But the recursive next hop resolving means routers do not check the reachability of the gateway. My router assumes that this subnet is reachable somewhere, it's somewhere already, and this IP is reachable somewhere in the public net. So when I set the recursive, instead of checking the reachability, it just passes my request to the next router, passes my request to the next, up to be able to reach this gateway. In very rare scenario, actually in static routing, you don't use it at all. In the scenario when you have one IBGP here, BGP, and another IBGP here, then recursive next hop resolving is very useful. But in normal routing, you don't use it. How you can use recursive next hop resolving? There are two concepts in the route: scope and target scope. These are just a number, nothing else, just a number. The default value of a scope for a static route is 30. The default value of target scope for a static route is 10. Now, for BGP and OSPF, we have different types of target and scope and target scope. Like you see, for a static route, scope is 30, target is 10. For OSPF, scope is 20, target. These are default values, just the default values. For IBGP, 40, 30. Now, if, for example, my active gateway is this one. This is my active gateway. If I increase the target scope of my intended route to something higher than the equal or higher than the scope of my main gateway, it resolves recursively. For example, if this one is 30, this one can be, it disconnected. When I change it to 30, 31, something over 30, if I change to something over 30, then I resolve the gateway recursively via my main gateway. This is recursive next hop resolving. In very rare scenarios, especially when you have BGP, you are using this option. Recursive next hop resolving.
Changing scope will reflect to target scope.
Target scope of the intended route should be equal or higher than the scope of your default route or main route. The other options in the route, you have one type. Check your route. When you want to add the route, there is the type. Type always should be unicast. When it's unicast, it works because you want to reach unique network. But there are also different things. For example, black hole, prohibited, and unreachable. All of them leads to have the request timeout, but with different messages. Same as the difference in firewall between drop and reject. Drop, silently drop, but do not inform the source address. But reject in firewall informs the source address about the unreachability. Same here. When you use unreachable, the user receives the message unreachable. When you say prohibited, the user receives prohibited, but user behind the Linux-based operating systems like Mac. In Windows, you still can get unreachable because prohibited is not recognized. But when you set to black hole, because black hole is a type of dead end, the user receives timeout. Timeout. Prohibited, unreachable. And we already talked about preferred source. For those traffic, when your router generates, you need to use preferred source if they don't have information about your other sources. Another concept here is point-to-point addressing. What is the minimum subnet you can use in the point-to-point link at the moment? Minimum subnet, the smallest subnet.
/30.
/30. Because the /30 have 4 IPs, one network, one subnet, one broadcast, source destination. It's okay up to now. It's /30. Same like here. 1111 is /30, 1112 is /30. 2221 is /30, 2222 is /30, 3331 is /30, 3332 is /30. It's a /30. But only in point-to-point link. Only in point-to-point link. Could be wireless point-to-point, Ethernet point-to-point, fiber, any point-to-point only. Any like PPP, like EOIP, like VPNs, they are also point-to-point. Only in point-to-point links you can use /32 single IP. To not waste 4 IP addresses just for 2 hosts. Because now there is a limitation, especially for IPv4, especially public. So if you can, with this concept, you can save 50% of your public addresses. Instead of wasting 4 IP addresses just for 2 hosts, you're going to use 2 IP addresses only for 2 hosts. How? One side IP address, single IP address like 11112, the other side 2222. But network in this side, the IP address of the remote side, network of this side, the remote address. You just need to put the remote IP address in your network. That's all. So right now, change the ring to point-to-point addressing instead of /30 to /32 and ping each other. For example, between router 2 and router 3, the IP address is 10.0.23.1. The network is 10.0.23.2. For you, opposite. Change the ring addressing and ping each other.
Ethernet 1 मा 12.1, Ethernet 2 मा 41.1. यसो गर्नु एउटामा चाहिँ /32 हाल्दैन के भन्दो रहेछ हैन त्यही भनेर चाहिँ
Done? You can ping each other only with single IP. In case of using private addresses, it's not a big deal because we have a lot of private addresses. But assume that the ISP who needs to distribute public IP for the customers, then for only one customer they need to use a /30 for the. Also, there are another way. If they use MikroTik PPPoE server, in PPPoE you can distribute single IPs. Most of the ISPs are using this because of PPPoE. Okay, first.